and welcome everyone to the Reading Revellers third series. Today we are going to talk about robotics and its future in a Canadian context. For that, we have Bikram Adhikari to open this series. This is going to be an initial series, and we are planning to do a lot more series in this particular topic of robotics and its future in Canada. Bikram is a software engineer based in Vancouver, BC, Canada, and he has experience working in several startup companies in Vancouver, British Columbia, Canada. And today he's gonna cover a key theme about helping Canadian robotics future. The three main points in his presentation that he's gonna cover today is gonna be why is it important to discuss the future of Canadian robotics? How is Canada positioned for the future of robotics? And what are the key Canadian frontiers to boost Canadian robotics future? With that, I would like to welcome Bikram Adhikari. And with that note, Bikram, please take this forward.
Thank you, Srishti. Hello, everyone. Namaste. Uh, thank you for the opportunity today. I got this request from Reading Revellers to talk about how we can help Canadian robotics. And having been in the robotics space as a student, as an engineer for some time, I felt that this is an important topic that maybe I could share some of my experience that people can use as we go forward in robotics and in Canada. I would like to do a presentation. So it's going to be a short presentation. It's supposed to be a conversation starter. So as Srishti pointed out, the three themes of our presentation today, based on the theme, I'll set the conversation starter, and then we can get into the discussion where you can ask questions. Please feel free to ask your questions on the chat. We can cover them as we go, or at the end as well. So yeah, let's get started. Hello everyone again. Today is 5th of November 2020, and let's talk about how we can help, I can help Canadian robotics. I'm a software engineer. I live in Vancouver, as Christy said, and I graduated from Institute of Engineering, Pulsar campus in Nepal. I went to Washington State University and UBC afterwards to do my master's. So today's theme, why is it important to discuss the future of robotics in Canada? How is Canada positioned for the future of robotics? What are the key frontiers to boost the future of Canadian robotics? Let's see. Again, my stress would be to make a conversation starter that we can get started in this dialogue. I don't think I am in the position, or this time is complete enough to cover the whole space of robotics. I will try to touch upon a few areas and use them as an example to make some comments. So robotics, just in case if you're not aware, or like just to get the right perspective, a Google search on robotics gives us this. Robotics is the branch of technology that deals with the design, construction, operation, and application of robots. So 4 areas of robots. So if you look at the word graph, I think the word graph is the number of times the word has been used in literature or in vocabulary somewhere in the search space of words. This is the graph. You can get in the time series. It looks like something happened in the 1800s. Nothing really took off until 1950s. Afterwards, it looks like, I can't really say the number, but it looks like maybe 80s or 70s. That's when it picked up once, and was in the 90s. It looks like on the top, took a valley for some time, and it's ramping up. And it looks like a plateau-ish, or at an inflection point right now in the 2019. So maybe we can look that in a different view. So this is a picture view of the same graph. So the early 1800s are those automatons. Automatons are those mechanical puppets. You set them to a fixed timing, they would move around, do certain maneuvers, and people enjoyed them quite a bit. This is all reference to Canadian Encyclopedia. You can look it up there. The ramp up the curve that we saw while in the 1990-ish was, I believe, would be I think the first AI wave, or the first wave of space exploration. This is the Canadian arm, strategically positioned on the ISS to do robotic operations outside of the space station. Then there was a valley. I think that the valley, to me, in my observation, I think the valley was the beginning of the internet, the uh, the rise of the search engines, the apps, and everything. I think that took things down a little bit for some time, and then it was open robotics. The ROS came in. That was the same time when ClearPath Robotics in Canada, in Eastern Canada, in Ontario, they started there, and then they really set the path for doing robust robotics in AI, and also paved path for doing open robotics applications in industry as well. So I'm within this space of robotics, and this is the robocosm from my view. A disclaimer that I'm within the space itself, so I don't see the whole universe. I'm looking at the part of it. I don't cover drones. I don't cover self-driving cars. I don't cover robotic arms. So please excuse me for not doing that. I just look around a few examples in mobile robotics that are relevant, that I could give some examples, or maybe based on some of my personal experience as well, that I could touch upon more better. So I've chosen these examples. These are all made in Canada, the proud Canadian companies doing amazing things. If you could see can you see my pointer? I just want to confirm. Christy, do you see my pointer?
Yes, I can see your pointer moving.
Okay, I'll start us off with the picture on the left here. This picture on the left is a warehouse, and there is a small platform robot, a square robot, that is carrying some stuff in this warehouse environment, moving things around. This is ClearPath's robotics spin-off company called Auto Motors. So they do warehouse logistic operations, moving objects from here to there within closed confinements. Similarly, if you go to the bottom here, this is ClearPath Robotics, a platform that has a wheels of similar to that of a tractor, and then can be used outdoors. So this platform was built so that people in industry or people in academia could put on their payloads and do their research work. And the ClearPath Robotics would leverage the ROS framework, or the robot operating system, to do a lot of software basic components, and then build applications on top. So they're really positioned right to do that work. And that is back in 2010-ish. The one on the top, on the second one here, this is a company from Vancouver. They're A&K Robotics. They're based in downtown. They're a UBC alumnus, and they are doing retrofit on scrubbers. So they focus to make software applications that can retrofit vehicles and do the job. So they are a robotics company that is focusing on a specific task and doing that great. So the next one here is the one that I look upon is this one with the face and an arm. This comes from Sanctuary Robotics, Sanctuary AI, actually. Sorry about that. Sanctuary AI. They're also a VC-based company. They are primarily focused on artificial intelligence, and I think they're exploring AGI, artificial general intelligence, which is a more complex AI. That's all I can say. So they're also a robotics company doing AI and robotics. So that's them. Now I'll touch upon the bottom three here, and then we can move on to the right hand side. And these are all proud Canadian companies. So I really want to go through one of them each at a time, so we really see like what's going on. So the one on the bottom left here is AIS. I think one of our participants is also a member there. So I think the person may be more qualified to make more comments. But they make platform, they make the robot, the whole structure and the software and everything for moving plants, moving pots in nurseries. So they're doing a pretty cool job there as well. They're based in Burnaby, I believe. And there's another company, Equation, the one with a gentleman standing. It's a platform, and it's an indoor platform for indoor greenhouses. So they are working on tomatoes right now. So they're automating the tomato growing process. This another one is it's also another outdoor robot. built by a company called Elios Robotics. They do detection for weeding. So they detect weeds in vineyards and other places, in orchards, so that people in the field can do other things, or do automation better. So they're putting some great efforts into achieving that as well, and it's going pretty good as it looks like. Uh, then there are other companies. For example, this on the center here, you see a company, Rigid Robotics. So it's a robotics company. They are making the CPUs, or the engine control units, ECUs, for mining vehicles. So this is like the CPU, the brain of the mining vehicle, so that they can be autonomous. So they are developing that technology there. They're also based in Burnaby. Uh, Another one, this is Kindred. They use reinforcement learning to sort out objects in warehouses. Another example on the top right here, a gentleman on a powered chair, and there is a robotic arm. It's built by Kinova Systems. They're based in Quebec somewhere. I don't exactly remember this city name, but they're based on East Side. Look them up, Kinova Systems. Cellular Robotics is based in Burnaby. They do underwater marine operations. So they are also a complete robotic systems development company that makes underground, like, mining, uh, underwater mining. Sorry about that. They also make submarines, I think. So they're invested in other kind of technologies. Uh, in the meantime, there are other companies as well which are focusing on the some key enabling technologies. For example, this gentleman with a robotic arm. This is a company called Genesis Robotics, I think, and they claim to have solved some critical challenges in motor dynamics for robotic arms. So they are doing pretty good, as it looks like. The one on the bottom here, this picture is from Earthcast. Earthcast is a company that does satellite imagery, and I wanted to point out that in the robotic space itself, like, there are people who make the real robot. There are people who make arms. There are people who make the only software, or they make a CPU box. So there are people who are doing robotics in several different ways, and all of these, what they're showing actually is they are able to solve these problems in the industry. And here is an example of it. It's not really like, oh, we can solve everything with it. People oftentimes companies are also positioned to say, like, oh, we have solved this, we can solve this and that. And many times people say, like, oh, you haven't done that yet, or something along that line. But what I mean to distill here is that robotics as a technology itself is, there are lots of pieces, and it's a big system, and everybody is only solving a part of the problem, and that's still robotics. And I think that's what we want to differentiate going forward. So let's dissect robotics. So robotics, as Google defined it, had four elements. So one was the design, the construction, operation, and application. So the design, construction, and operation has been a constant evolution for a period of time already. I think that, so from my perspective, the fourth industrial revolution, or the industry 4.0, as some people would like to call it, would predominantly be in the space of application. So there will be key innovation in the design, construction, and operation. I'm not denying that. But a significant contribution in the industry 4.0 is going to come from applications. So industries that understand their problems very well, people in the technology space who have the technical know-how, when they get together to come up with a solution that is problem oriented and doesn't have all the bells and whistles of a fancy robot that we assume, there may be a good way out. So there is a very popular saying in the software world. They say, your company may not be in a software business, but eventually a software company will be in your business. You can look this up online on Twitter and other places. People have made lots of comments about this being an exaggeration and whatnot, but I'd like to get this in right context here so that it doesn't look like an exaggeration. So whenever any company, let's say a press that is doing publication printing, for that matter, they are busy taking the news, organizing the news, doing the prints and getting those prints out to market. Now, suddenly there is this technology called internet, and people can write on computers, and then they figured out how to make better presentations, and then they suddenly had a better edge than newspapers. And now suddenly these newspapers had to adopt with this, right? And we have seen that come along in taxi industry, for example. Uber is another example, right? So we have seen a lot of that, but that doesn't mean that every industry is going to be disrupted, as this may also appear like. It's not the case. So going forward, if this was true for robotics, so if you don't do robotics now, a robotics company will do you. We'll see if that holds true or not, or to what extent will that hold true. I think it would be yet to be explored, but this is something that we have to be aware of. So if this is the case, if we see robotics as like we have solved a lot of technical challenges, its adoption, its applications, it's finding the right market, then we may be able to come up with a good strategy if we follow these three guidelines or principles for robotics driven businesses. So we need a proven understanding of a market need, whichever market we are in. So this needs to come from the market itself, and this is one of the reasons I'm trying to make this presentation about robotics in Canadian context, is that uh, really the market needs should not see robotics as something that is taking away jobs or making things difficult, but rather an ally in this fight against this pandemic, if you will, right? So that's how we want to see this as, and I think whichever industry or whichever partners see it this way, I think they could take leverage from robotics. And now the other piece is people who know that have a good knowledge of the technical challenges. So what can be done, what cannot be done. That's where people with the technical expertise in robotics would come in, and when these two people meet, or when these organizations meet, I think, and they work on how they improve their process and productivity through automation, there may be some way to make a breakthrough. And uh, and and I also believe that this kind of a dialogue helps us solve our problems rather than look at a fancy robot that is not able to do much job. So if that's the case, and if robotics is supposed to be an enabling technology, then when this so how this enabling technology would integrate, I think that comes as another question. Or how robotics is going to be introduced. It's already in our lives, and how it's going to be introduced further, we'll probably see it as coming as like workflow integration. So what that means is some part of your job is going to be done by a machine, or a simple example is a calendar that manages all your meetings, right? So that has been done already, and we as users had to transition ourselves to learn the digital calendar and then sort our things. So that's a good example, right? So I think for robotics as well, we need to find those skill transition strategies, and we have to apply those rather than thinking it itself as, oh, it's going to shift the entire workforce from, or swing the entire workforce from one way to the other, or create a big divide in this workforce space. I think we really want to avoid that for robotics going forward. And that's where this second point comes in: empower people to adapt to new technologies. So the technology should be introduced in a way that it's not taking away people's jobs and helping them to do better things. I think that's how it would come. And if that works out, then safety, quality, and productivity, as long as we can nail those three KPIs, and deliver, I think then robotics technology in the market space going forward, I think there is quite a big opportunity ahead of us. So coming to the theme, I think I really like this to be a conversation starter. My objective is to actually just make robotics simpler and help us stress more on applications, making some strong assumptions that the technological pieces are solved. I think that's okay, given we understand that there are people in key robotics fronts who are doing those key innovations as well. The big push in the next time ahead of us would be in the industry 4.0 would be in those applications. Yeah, that said, I think if I were to make a quick comments on on these questions. Why is it important to discuss the future of robotics in Canada? I think the pandemic is shifting the workforce quite a bit, and the other force that is poised to shift the workforce is that's robotics, right? So if both of these are here, we knew robotics was there. Pandemic has come along. This variable, I think, these two variables, when they come into interplay, there can be really quite innovative work that can be done ahead. How is Canada positioned for the future of robotics? I think we have all the pieces. We have great talent. I think Canada is positioned to bring in more talents. I think there will be a huge demand for people in robotics or in robotics applications space in years to come. So I think the country needs to focus on how we supply that demand for workforce in the robotics space. Canada, I think it'd be great if you can focus it as a country, how we can do that. I think that'd be great. What are the key frontiers to boost the future of robotics? In Canada, I'm not in a position to actually call for any frontiers. What I believe is that any industry who is ready to adopt to new technologies takes on big challenges and wants to solve them through technology. I think they will come across robotics technologies, one or the other, and at that point, you just need to go and find your experts in robotics or in your industry. And find ways to solve them, and be your leaders in your own frontiers. I think that's ahead of us. And with that, that's me. That's my presentation. Thank you very much for your patience with me today. You can send me emails to ask any questions. It's robosherpa@gmail.com. Um, I leave this slide open and pass it on to Srishti. Thank you very much.
Thank you, Vikram, for your talk and your presentation today for covering the robotics and its future in a Canadian context. Thanks for doing this and being the conversation started on this topic. As I mentioned before, we are planning to do a lot more series on this given topic, but I think this is a great start. We can continue this topic further, and it's very, very relevant in today's time, especially in this pandemic era. I would say we are seeing that there are so many changes going on, and people, consciously or unconsciously, they are embracing new technologies, be it a younger generation, older generation. We all embracing new technologies. And as you mentioned, like the bodies is an enabling technology. And I think it has a huge, huge potential in doing a lot more than what it is doing right now in Canada, especially. It's very interesting to see so many companies doing a lot of interesting and exciting work. It seems like it's everywhere. I mean, it has application in underwater, it has application in space, it has application in land. So it has like a huge, huge potential for sure. And then, and also like interesting areas for, as like you mentioned, artificial intelligence, uh, which is which is coming in pretty much hype these days because it's such an interesting um, it's such an interesting concept. And it's not just robotics, but it also applicable for their software applications as well. There are a few questions from the audience. But before going to the audience, I do have a few questions I would like to ask that before going to the audience. My first question would be, how is a normal system different than a robotic system? So if you have a machine, how would you differentiate it's a robot or if it's a not robot? I think this is like a very interesting thought that I have that has been like triggering my mind most of the time, because sometimes I fail to understand that this is a robot or not. Say for
Mm.
example, a car, it has wheels, it can sort of like drive itself if it's a self-driving car. And there's so much of new technologies enabled into the car, AI, say object detection and things like that. Even like in some modern grade cars, even detects the blind spot and then sort of triggers and helps you in knowing if there is a car in your blind spot. So I think it would be good to understand how to differentiate a normal machine or system from a robot being not a robot.
Uh, Thank you very much. What's a robot and what's not a robot? if you go into a robotics class, mostly everything will start looking like a robot. And I tell you why. My professor in my grad school at UBC, in this computational robotics course, we had this conversation. The basic premise of robot is anything that can think or see or observe, think and act. If it has that process, then it can be modeled as a robot. So anything that has sense, think and act, you can probably call that a robot. Now, the word robot and robotics itself, as you can see in that word graph, it really started in the 19 late night after 1950s. So scientists or some pioneers, Asimov, three laws of robotics, and others. I think they try to define robotics in their behavioral form, how a robot or intelligent AI would behave. The other example, if you look back in the history, that puppet, that doll, the automaton that I showed you earlier, that's also a robot. Back in the day, people thought that was a robot. So robot is really a concept. It's a model of how we observe a system and how we design a solution for that system. So I can be in a position where I can say a computer is a robot. So it's really a concept, rather it's a construct rather than anything.
All
Any
right.
other questions?
Yeah, that sounds good. Thank you, Bikram, for covering that question for me. I think the other question that I have is Canada is a huge country, it's a big country. How do you see robotics application varying from one province to another as compared to, say, in rural areas versus suburban areas versus in the core cities?
Mm. Uh, well, I think there are challenges which are local. There are challenges which are regional. There are challenges which are global, and we can address them in different ways. One differentiation, for example, could be uh, the tourism industry in Vancouver or the movie industry in Vancouver. That is not elsewhere, right? Uh, for example, the other thing is Vancouver is so proactive on sustainability and climate action, right? So that doesn't happen elsewhere. So we in Vancouver, in Canada, we have a specific position and specific role to play in Vancouver. So that makes us unique, right? So now, so that's how Vancouver is different from other provinces. It has its own uniqueness. I can say some of that for Vancouver because I've lived here for some time, but I'm pretty sure there are experts in other parts of the country as well who can identify their own challenges in their own region. So that I think there are, and yes, I can speak for the entire country. I can speak for the world, but I believe that within the scope of my understanding and where I'm at, I think there are more important things to discuss in Vancouver than other parts of the country at this point.
Thanks, Vikram, for answering my questions. With that note, I would like to go over our audience's question. We have a few questions here, and we do have like interesting questions. So I'm really looking forward to asking you these questions here. So first, I would like to go to Naresh Koirala's question. First question he's asking is, what is the difference between Canadian robotics and other robotics?
Like I said earlier, Canadian robotics is built in Canada, made in Canada. It's Canadian ruggedness. The ClearPath Robotics company, based in Waterloo, they do take a pride on driving their huskies in the snow and doing the jobs there. So I think Canada itself geographically has some advantages. But all that being said, electronics is electronics, software is software, AI is AI. It's geo agnostic, if you will. So I cannot really say that it's like our is better than others. But we have research like people in research who are making breakthroughs in Canada, and we have people in industries who are doing the pioneering work as well. So we have the resources, or we have the team that is able to deliver as compared to others as well.
All right, so let's go to the second question. What is robocosm? Right, I think this is an
Yeah,
interesting phrase that I saw in your presentation. I never seen it before. So would you like to
yeah,
describe something about it?
yeah. I really apologize with the language experts here. I did take a little courage to coin a word. So the robocosm is the cosmos of the robot. So it's a robotic cosmos, if you will. I just merged those two words together to create a robocosm for Canada. And also, as I said earlier, I'm inside the robocosm, so I can't really see the big picture or the whole picture. So that robocosm is my perspective on the robocosm. I think it's much bigger. I think there are people in different companies which are just getting started doing great work in robotics in Canada, and we'll know about them soon.
Okay, so let's move on to the next question. How does a typical robotics production team look like?
That's a great question. I think that that question also touches upon one of my key themes is how do we, what is a robot and what is a robotics team? And what kind of teams actually qualify as a robotics team? A robotics team could be a complete software engineers team as well. A robotics team could be a completely mechanical engineering team as well. A robotics team could be a combination of all of this. A robotics team could be an astronaut and a couple of mechanical engineers. So it really depends. And that's one of the reasons as well. I don't want people to confuse robotics for one or the other. It's one and it's all. So if you have a problem that can be, if you think that can be solved with robotics, you should go and talk to your expert, whoever your expert is in robotics. They'll probably give you a distilled view of like what part of the problem you're solving or that makes a breakthrough for whatever problem you're tackling at the time. So again, if I didn't answer that question, it could be anything. I can tell you, I worked in a team where there was one software engineer, one mechanical engineer, one electronics engineer. I worked in a team where they're all software engineers. I've worked in a team where there are people from all different engineering, like agricultural engineering, mechanical engineering, physics, and all of that getting together to do cool projects. So it really depends. I worked with occupational therapists for some time too when I was working on the smart wheelchair. So it really depends on the problem you're solving.
Yeah, I think that's the exciting thing about robotics. That's very, very applicable everywhere in different sort of application areas, be it agriculture, underwater, space. So being in these different areas, you might need like expertise in the particular areas. So based on that, it might be different that you might need a physicist in your team if you might need a occupational therapist in your needs. So based on the application, it's gonna be like very, very different on how your team looks like. Right. Thanks. Thanks, Norris Koraju and Bikram for the question and the answer. Next, moving on to Praveen Joshi's question. Why did NASA require a Canadian company to build the arm given that they were able to handle the rest? And then also he's mentioned that soil sample was collected from an asteroid recently that I believe is still making its way to Earth. The sample was made by a Canadian company. How significant is that event to the future of Canadian robotics and how will that shape the future of space mining?
Thank you, Praveen Joshi, for your question. I don't think I qualify to answer that in quite detail, but if I understand it, let's see. Why did NASA require a Canadian company to build the arm given they were able to handle the rest? I think it's a strategic partnership. I think the US and Canada are allies in a lot of missions, so I think it was a strategic choice. And I think being Canadians and being in Canada, I think we should feel really proud about that strategic positioning Canada has in the International Space Station. And fact of the matter, that robotic arm was built by MDA. I think they have their office in Richmond here as well. And also just to mention the other company that I talked about earlier, those were doing satellite imagery or satellite data collection. The Earthcast company based in downtown Vancouver, they're also a spin-off from MDA. So I think just being in that space and having the strategic positioning gave us a lot of opportunity, right? So going forward, absolutely, right? So that robotic arm and other projects in the future, the alliance with the United States, I think that's going to go forward. Hopefully, the election is also going to turn in favor of all this conversation, but that's yet to be found.
Thanks, Vikram, for covering Pavin Joshi's question here. Moving on to next question, which is from Rakesh Shrestha. His question is, robotics doesn't have the kind of appeal that some other software engineering sub-disciplines enjoy, like the web development, data science, machine learning. Majority of computer science students, they gravitate towards those. What do you think is the reason?
That's a great question. Uh, it's hard to answer, but it may be obvious as well. Let's think about it. Robotics doesn't have the kind of appeal that some people in other software disciplines enjoy. So people in web development, people in data science and machine learning, they don't have to deal with hardware. So that's one of the key differentiators. People shy away from hardware, a little hesitation. The other thing is that's having to touch hardware also brings a lot of challenges. It's a barrier to entry into market because the capital cost to get into the market is really high in the hardware space. So there are only a few companies that are doing robotics, and actually the other also important fact is only a few robotics companies scale up because it's really hard to scale a hardware systems integration automation robotics company. It's really hard to do that. So that's one of the things as well. I think people need to find that space. And talking about now how or what do you think is the reason? I think that's the reason. But the other part is we also need to think about, based on my presentation, robotics is nothing. Robotics is a perspective. It's a way of looking at things, right? If you see it that way and then you start solving problems in the industry, people who are doing data science or machine learning would be coming in crucial, right? And the robotics technology that would be used as well, I think would take a lot of advantage. Right now I can tell you that there are lots of companies who are dying to get really good web developers for them, who are dying for good data scientists to work in their team, because there are just a few robotics people who are very crazy about robots, but they don't have other expertise. And people in other expertise, if they find their passion, or if they know that there is a space for them to contribute in robotics, they will be more than welcome. And I do see in future that trend is going to come.
Okay, so Rakesh has added some other point here. So he's saying a general concern regarding robotics and other forms of automation is that it takes jobs away. Say self-driving vehicles, they take jobs from the normal human drivers. Are these concerns valid?
uh, I'll turn that question and say these questions are not invalid. I'm not sure if these questions are valid, but I can say that these questions are not invalid, and they do come from a lot of concern. I think it's fair that there is a saying, a technology that is so good looks like magic, and magic, if when people don't understand it, well, if it's not hurting you, it's all right, but if it relates to you, then it can be really eerie for people. And so that's a concern, and that's also one of the things I wanted to highlight in my presentation, that this strategic integration of the workforce is the key to make this change possible. And I think being in the robotics space as robotics engineers or the software engineers in robotics, I think we have the responsibility to 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 take this seriously and be very careful about what we are making. Actually, I think it's just because you're an engineer and you're in a company and your boss pays you to do something doesn't really mean that you have to do it. I may be making a strong statement here, but I think people have to put their integrity as a robotics engineer, as a robotics professional first when doing their job. I think it's important in every or any engineering profession for that matter. And robotics is very important at this point. It's really special.
Thanks, Bikram, for answering Rakesh's question. Naresh Korala has also another question to add here. Do you see the need for a social scientist in a robotic team?
Absolutely. Uh, Actually, my research when I was at UBC touched slightly on the social side of the robotics. So it had to do with user experience. So there are people who are there's a field called human computer interaction and user interfaces design, and there is space, and there are a lot of people who do the sociometric or socio-psychometric analysis of using these kind of technologies. So a social scientist would really come in handy in user verification, or making sure that we understand the user really well, or what you're developing is actually catering to the needs of the user. I think these people with those kind of background would come in really really handy.
Sounds good. Thanks, Vikram. With that, there are no more questions from the audience. I would like to remind the audience again, if they have any more questions, please feel free to send that over on chat, and I will be asking those to Vikram. Meanwhile, yeah, I would like to touch upon the social impact of robotics. Rakesh mentioned that, oh, it might be a concern for some people that, oh, it's like taking normal people, like humans' job away, like self-driving cars taking away jobs from like taxi drivers or even like normal people, right? So, in say an automated, um say a cleaning machine, like automated cleaning machine in in an industrial space might take away, say, the person who's the human being's job, who is actually doing all that manually by himself or herself. How do we tackle those kind of challenges, the social challenges that robotics field has brought in, and then as to encourage people, that's not taking jobs away, but rather it's just taking away the the harder, the dirtier, and the duller job from people. Then people, they have like more space to do more interesting and more exciting jobs, other than to go and like clean, say, corridors, for example. That can be done by a robot. You just don't have the human being. A normal human being doesn't have to do it. So how do we sort of um, tackle those social challenges? I think that's one of the important areas for somebody who's in the robotics field
Yeah,
compared
yeah,
to, say, web development or data science, right? How
yeah.
would you how would you think that we should be tackling those challenges for a person in robotics domain?
Yeah, this will remain a very strong challenge for the robotics industry. So it's hard to say. I can say I'm not in a position to do anything about it right now, but that keeps me concerned every time when I think about a robotics technology, how it's going to be adopted in the workforce. Uh, so I think a good example, I think, is there are a few good examples from the past that maybe we can derive from, that would make us not feel so much pessimistic. People in the experts in the tech industry have often said that we often overestimate the consequences of our actions short term, and often underestimate the consequences of our action over the long term. We often miss that. So that brings me to this Luddite movement from back in the days. I think that's early 1900s. People in the textile industry, when people saw those looms that could like make those clothes automatically, the workers there, they freaked out, and some of them they went and broke those machines. That was it's historically called the Luddite movement. I think you can look them up. So I think the technology is a force. So technology is a force, and this force, you can't fight this force. It's hard to fight this technology. The only way to go forward with the technological force is align with it and steer it in a way that it lands us in a good place. Technology is a big beast. We have to be very careful how we drive this beast. So we can't go against this beast. We have to align with this and land it properly. So that's why for the workforce as well, the another example that I want to mention about is accountants freaked out when they saw the Excel spreadsheet. It's back in the day, right? And well, now fast forward, like accountants are still there. I think we have as a human being, as a human race, we probably only used 10%, 5% of our brain, and then our capacity to do creative things. Uh, we should first thing is we should feel responsible for transition of all this workforce in the workforce going forward, creating employment. I think that would be crucial. But the other thing is that I actually snapped there. I lost track. But anyways, I think integration will remain a key. I think integration will remain a key, and then people have to try. Oh, okay, I got my thoughts again. We basically what we want to do is, for example, so a person who's a let's say a security guard whose job is to watch around, look out, and do a lot of things. Uh, a lot of his job that is standing or mundane may be automated, and then he could be sitting in doing that job rather than standing. He could be doing that job as an office desk job rather than an outside field job, right? A lot of so that's how you see. So a person who was holding a rope inside a tunnel and doing some cleaning job, now that part somebody else, some machine would be doing it, and that person would be in the office or in a cabin somewhere in an AC heated environment that they could work. I mean, that's what we should aspire for. Is more convenient to do our job, doing the same job. I don't think that it would be a radical shift from one job to the other. I think we'd be doing the same jobs, just the tools would be different. I used to use a pen and a paper before. I don't use them anymore. I think that's the kind of transition it we'll see rather than people completely losing their jobs or going crazy. There will be some of that, but I think we have to be careful how we transition.
Yeah, I think it's not just robotics, it's like technology in general that we're seeing the shift, and we'll keep on seeing the shift and the future to come. So I think that's how we just adapt ourselves and adapt to the new technologies and changes. Just saying that it's creating more creative jobs and taking away the duller, the dangerous, and the dirtier jobs away. Doesn't mean that we are taking jobs away, just meaning that we are just creating a different shift of jobs of people out there. With that note, I would like to thank all the audiences for their great questions. Yeah, this is the final question that I'm going to read from Rakesh. He says, touching on the so good it's like magic, how do you think development in robotics can be moderated, regulated? There are AI chatbots now that can write a fake news article that looks like a person has written it. How can similar developments be moderated in robotics? Is it just up to the individual roboticists to do the right thing?
Thank you, Rakesh, for bringing that question. And I like to quote my professor from UBC on that. Uh, uh, Alan Mackworth from UBC, I had a conversation with him once, and we talked about this, and the idea was we need PNs for robots. We need professional engineers in robotics. That's the regulatory body that is like engineers who sign off on the quality of robots that are built. Just like engineers who can sign off on quality of structures, buildings, mechanical frames, and everything else. I think the robotics industry also needs professional engineering paradigm. We need a way to get engineers certified and have a way to regulate that. I think that's actually missing, and we as engineers, I think that's one thing we can focus on or put some effort to actually realize that in Vancouver or in BC.
Okay, so that's about it. Thanks everyone in the audience for the questions. Thank you, Bikram, for answering every question. With that, I would like to thank everyone in the audience, and I would like to say special thanks to Bikram for doing the presentation, giving the talk, and also doing this as the initial conversation starter for the Canadian robotics and its future. And definitely, we will be organizing and planning many more series in this particular topic. And I would be really happy to see you in the future series as well. And with that, I would like to end today's Reading Reveller series. And yeah, thanks everybody for joining. Thanks for these great questions. I really look forward to having you guys in the next series as well. Yep. So that's it for today. Enjoy the rest of the day and see you in the next series. Thank you, everyone.
Any customer